Alrighty, let's go ahead and get started. I'm going to switch over to this thing. Half my browser is going to be in the way, but that's fine. Today I'm going to talk about... Make sure I actually name the stream properly. Okay, good. Today we're going to talk about something that's called test-driven development, while I turn down the music because it's just a little bit too loud, but that's alright. It's a good track. We're going to be talking about test-driven development. Now, even experienced programmers might think that the way that you make code is someone gives you a problem to solve, because that's what software designers are. We're problem solvers. Somebody says, we need code that solves some problem, and we write code that solves their problem. That's what we do. A lot of people might think that the way that you write a program is, okay, what's a good way for my program to run so it will solve that problem? Or if you have to make a lot of objects, you think, what objects do I need? Okay, I'll code those objects now, and then I'll test and make sure they work. Something that's actually very useful is to do it backwards, do it the other way around, where you actually test your code before you write your code. Now this sounds kind of counterintuitive, but it makes a lot of sense. So for example, let's say that I'm writing a method. I'm going to make it a Boolean. Actually, no, I'm not. I'm going to do something else. Let me make a new class. And this class is going to be a total static class, meaning I'm not going to create an object. Every method in it is going to be static, which means it's just going to take inputs and have some outputs. So I need to think of a good idea. How about my math? Java has a math class that does some math stuff like absolute value and find the power of something or the square root of something. We're going to make something very similar where it's going to be abstract. If a class is abstract, it means you can't make an object out of it. Cannot make an object out of it. And we're going to make a method called factorial. And that we're eventually going to fill this in. Let me just do that. I'm going to comment it up. Returns n factorial. So this is the function we're going to make. We're going to make the factorial function for math. If you don't know what factorial is, it's basically you take a number, you multiply that number by every smaller integer. So factorial 6 is 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. That's what factorial is, and that's what we're going to do. This should be over here. Much better. Even more better. So in test-driven development, or sorry, in the way I was talking about, what you would do is, okay, well, I would write my code in here first. Some finished code, and it would do something, and then you say, okay, I finished my method, time to test it. Int factorial 6 equals factorial 6, and then, you know, you'd print it or whatever. Oh. Then you'd print it or whatever, and if it prints the result that you wanted, then you say it's a success. In this case, it's going to print 0 because I haven't written the code yet. This is how most people tend to write code, where you think of how you want to solve your problem, or you think of how you want to write your code, then you write your code, then you test it. In test-driven development, you start by testing your code even though you haven't written it. So all we know is we're going to have a method called factorial. And here is how you do test-driven development. Normally, if you're going to write what are called unit tests, you would use a library like JUnit is a pretty popular one, or you'd use AssertJ. But I'm going to use a reflection. Oops, I got to import everything. That's not the import button. I forget what my import button is. I'm using a reflection unit test. And basically what that means is test project. What that means is the main method is just going to find every other method in this class and run it. That's all it means. So each test in a reflection test is going to look like this. The reason I'm not using JUnit is because I don't want to import it. You have to learn an API and all that. This way, and I guess I can post this somewhere if any of you care. Maybe I'll just keep it up here so you can stare at it a little bit. It's a little bit unformatted, isn't it? All you're doing is going through all the methods in this class, ignore the main method, call every other method, and just remember which ones return true. Public static boolean test factorial. And this is a bad way to do unit tests. I'm going to start with the bad way, and we're going to slowly improve our tests. So one way we could test it is if mymath.factorial of, let's say, 4 equals, what's 4 factorial? 4 times 3, which is 12, times 2, which is 24, times 1 equals 24. Return true, otherwise return false. Now this test is going to return false because I haven't written my code yet. I'm just going to run it, make sure. Okay, test failed, and it gives me the name of the test. Maybe if I make this a little wider. Test failed, test factorial. That's the name of this method. So what I would do is I'd write some code, and then I would run my tests and see if they work. Now there's a kind of mantra behind this called red-green refactor. Okay, red means your tests are failing because you wrote your tests first and your code is obviously not going to work because you haven't written it yet. So it's red-green refactor. So the red is you write your tests and all your tests will fail. The green is write your code to pass the tests. Refactor is clean up your code a little bit. If anything can be maybe extracted to a new method, or if anything can be optimized, maybe you change some variable names so that other people looking at your code can make more sense of it. Refactoring is just general improvement of the code without changing its functionality. Okay, so red, green, refactor. That's the mantra I want you to learn. Red means write your tests. They'll fail because you don't have code yet. Green means write code to pass the tests. And then refactor means improve your code as much as possible without changing what it does. Okay? So that's what we're going to go through when we make this factorial function in mymath. I'm not even going to keep this comment here. We know what factorial is supposed to do. Alright, so remember, green is make your code pass the tests. It's not make your code amazing, it's make your code pass the tests. It's up to the person writing the tests to make sure your code is good. Because what this ends up doing is each one of your tests will end up being kind of documentation for what your code is supposed to do. So if I have a test here, this test says if I give 4 to this function, I expect 24. That's what this test says. If I call factorial on 4, I should get 24. So here's a good way to pass the test. Ready? Okay, I'm going to pass my test. All tests passed. Success. Now, of course, our code is really garbage, because this is not what intuitively we want the factorial method to do. We want it to do the actual math thing. So you, as a test writer, and possibly as the code writer too, if you're writing your own tests, you have to think of every possible thing that a user could possibly do for each one of your functions or each one of your API calls, each one of your libraries, whatever it is, each one of your objects. You have to test every input that you can think of. Now, of course, we don't want to test this from 0 to 1,000,000 because that would take forever. What you want to do is you want to test, and this goes for testing in general, not just unit tests. You want to test things that you know are incorrect. So, for example, negative numbers. You cannot take a factorial on a negative number. So if I run this test, actually it won't even have a value, but I'll put 0. If I run this test, of course it's going to fail because it's returning not 0. So you will write one test, this is the rule, you write one test for each case of whatever your code is supposed to do. So this test name is actually kind of bad. Test factorial rejects negative numbers. Or actually, a better one would be returns 0 on negative numbers. It's kind of long, but when you write unit tests, you want them to be descriptive like this. Test factorial returns 0 on negative number, or on negative input. maybe negative input, or return 0 for negative numbers or something like that. So we can modify our code. If n is less than 0, return 0. Good. So now we're going to run this test, and it passed. So let's make another test, because factorial can do other things. Test factorial returns 0 on 0 input. So factorial of 0 is 0. Dot factorial of 0 equals 0, return true, otherwise return false. So this is another test, and it's going to fail. So one test failed and one test passed. That's what we expect. So now we're going to write some more code. If n equals 0, return 0. So now our test will pass. So we're in the green now. We were at red, now we're at green. But now it's refactor time. There are ways to improve this code. Maybe you can see it. Hopefully it's not too cryptic. But these two lines of code can actually be combined like this. So now if n is less than or equal to 0, we're going to return 0. Oops, no main method here. So we'll go back to our tests. They still pass. We have not changed the function of the code, we've just made it look a little better. Alright, now let's test factorial on 1. Returns, I'm just going to put the number in there, returns 1 on input 1. I'm just going to copy this. If factorial 1 equals 1, return true. Alright, so now we can make our test pass, we just do this. Okay, all tests passed. Time to write another one. Public static boolean test factorial returns factorial for numbers larger than 1. Alright, so this is where the actual code is going to matter. So we'll paste that in there. And what we could do is we could put like different values in here. We know that 3 factorial is going to be 6. And we know 4 factorial is going to be 24. And ideally you'd probably want to either make this a random number every time or put several tests within here because they're all pretty much testing the same thing. And let's put a higher number, factorial 7, which is going to be, let's see, 120, 6 is 600, 620, and then 620 times 7 is something I can't really do in my head. Let me just get a calculator out. What was it? We were in scientific mode. 7 factorial is 5040. Alright. What we're going to do, though, is we're going to reverse these, so if they're not what they expect, we're going to return false. I could make these separate tests, but I'm choosing to make these one test because they're all testing the same thing. And if none of those fail, then that means they've all passed. So this is the last test, and this is the one where our code's actually going to be tough. So we're passing 3 out of 4 of our tests. And I get to talk about recursion now. So remember what factorial is. You take a number n, factorial is, I take n, multiply it by the previous number, I take the result of that, multiply it by the previous number, and so on and so forth until I hit 1. Actually, you can kind of shortcut it and say until you hit 2, because anything times 1 is just redundant. So here's where our code's going to be. If n is less than or equal to 0, return 0. All recursive functions have to have what's called a base case, which is how the recursion ends. Oh, by the way, there's something you guys can do. This is cool. I want you guys to Google recursion, because it'll tell you what it is. I'm going to Google recursion. Did you mean recursion? Click on recursion. Click on recursion. This is actually kind of a joke, but it actually is recursion. So this is one of Google's better jokes. If you Google recursion, it'll ask you if you meant recursion. And so you can click on that to find out what it is. Anyway, so our base case is when we get to 1. I could make it when we get to 2, but that would require 1 extra line of code. If n equals 1, return 1. That's our base case. Else, return factorial n minus 1. Did I do that right? Oh no, it's n times factorial n minus 1. And this return is redundant. So I already talked about recursion once. And I wrote pretty much exactly this function. I don't remember if it was exactly this function. But let's see if our test passes. I think it should. Yeah, all tests passed. So this is how you calculate a factorial in Java. This is one way to do it. There are other ways to do it. This is called head recursion, but there is something called tail recursion where you actually store the value of the factorial first. Wait, I don't know what I'm talking about. Never mind. There's two different types of recursion. One saves stack memory, and the other does not. But in most cases it won't matter. The difference won't matter. 0 not equal to 1. You're correct. Unless are you suggesting I change one of these? 0 is only not equal to 1 for extremely large values of 1. Sometimes 0 is equal to 1, but you have to be doing like statistics or calculus for that. That's a really stupid joke. But anyway. Oh, the factorial of 0 is 1? Okay. I haven't checked my mathematical definitions recently. So if n less than 0, then we return 0. And actually I can refactor this code a little better. Less than or equal to 1, return 1. Because if it's negative, it won't hit this line of code because of this return. So if n is less than 0, return 0. If n is 0 or 1, which is what this line says, return 1. Then we do our recursion. So thanks, YakiSC. I didn't actually know that a 0 factorial was doable. But I guess that's just how it's defined. Yeah, when you typed, here's what he typed for those of you who maybe can't see it. He typed at Shard Phoenix, which is me, or Shards of O really. I have so many names. Anyway, he typed this. This is what it looked like. That's what he typed. This thing right here, this 0 factorial equals 1, but I read it as 0 is not equal to 1. Totally just flew over my head that he was trying to correct me. N factorial equals n times n minus 1 factorial. Yeah, that's exactly what we've got here. So if n is a negative number, that's just bogus. So we return 0. If it's 0 or 1, we return 1 because that's how it's defined. Otherwise, we just return the current number that we're at times the previous number. So what's going to happen is I'll just do it for factorial 3. Okay, I'll do it for factorial 3 down here. I'm going to make a giant comment block because this might take up a lot of space. Alright, so the first time we call it, let's say we're going to call factorial, let's do 4. We're going to call factorial 4. Okay, so it's going to run through its code, and it's eventually going to call factorial 4, it's going to return 4 times factorial 3. And I'm going to do this. Oh man. Comments don't format very well. This is going to return. Yeah, I mean, if n equals 0, return 1. Yeah, that's what I had. I had, before I corrected it, I had this, and then I had this. That's what I used to have. But I'm talking about, what? Oh, no, semicolon. That's what I had, but I'm talking about red-green refactor. So after you've written your code to pass your tests, you actually want to make sure that your code is really good. This is kind of redundant. I mean, the CPU cycles involved in doing both of these is pretty minimal, so it probably doesn't matter in this case. But if you can see a way to combine two lines, then you should probably do it. And if it's really complicated, maybe you wouldn't do that. If you're combining like 7 lines of code down to 1 line of code in a clever way, maybe that's not the right way to fix up your code, because it might be harder for somebody else to read. But I thought this was appropriate to make my code a little smaller. So we're going to call factorial 4. I'm just going to kind of draw out what the procedure is going to look like. So inside factorial 4, it's going to skip these 2 lines because 4 is not less than 0 and it's not less than 1. It's eventually going to call return 4 times factorial 3. N less than or equal to 1 could be replaced by n equals 0. Oh yeah, no, I see what you're saying. Yeah, you're right. He's saying if I do this, it's the same thing, because when we do this line, let's say n is 1 up here, it will get to this line, it'll return 1 times, and then it'll be 0, so that it'll be at 1 times 1, basically, is what it's going to return. It's actually faster computationally to do it like this, because otherwise you're creating another method on the stack, you're doing additional multiplication. Even though it's 1 times 1, the computer still actually does it. So it takes up a little more CPU time, but that is technically correct. You could do it either way. You might find that in your refactor process when you're improving your code. Alright, I haven't actually written this out, so we're going to return 3 times factorial 2. Then we're going to go over here. Return 2 times factorial 1, and then because this is factorial 1, we've already told it we're going to return 1. So just as fast because of branching typically, yeah. It's probably actually a little bit slower, but anyway, it doesn't really matter. The slowdown is negligible in this case. In other cases it may not be. Some recursive functions are monstrous and they take a long time, but this one does not. So here's what recursion looks like. We've called factorial 4. It's going to go down here, it's going to return 4 times factorial 3, which is inside here. So factorial 3 is going to return 3 times, and then factorial 2 is in here, which is going to return 2 times factorial 1. So factorial 1 is going to return 1, we'll just move that up. 2 times 1 is 2, 3 times 2 is 6, and then 4 times 6, we're going to end up with 24. Recursion never gets used when performance is important. Sometimes it does. There are a lot of things that you can write another way without using recursion, but sometimes you just got to use recursion. Sometimes you have to. There aren't many cases where you're forced to, but a lot of the times it's usually easier. And the performance impact in most cases is not that bad. If performance is involved and recursion, like if you know that you're going to call the same function a million times, then recursion's probably pretty terrible. Your program will probably crash. Give an example. Let's see. Do I have any recursion that I've done in a project? If you're parsing like a JSON or an XML, recursion, there are actually ways to do that without recursion that are kind of tough. I can't think of an example where you're forced to do recursion because there's no other way. Most of the time it's easier to do recursion because it's easier to understand if somebody's looking at your code. I'm trying to think of one where you're forced to. I can't think of one where you're forced to, but I'll keep that in the back of my mind, and if I ever run into one, I'll write it down, and I'll let you know. You might actually be right. Because I'm trying to think of something that's recursive that you need to be recursive, and I don't know if you can. I mean, I don't know if you're ever forced to. As I'm starting to think of this as a mathematical problem, I think you're actually right, because you can transform any recursive function into a shifting function. Yeah, you're totally right. YakESC. I've never actually thought about that. I knew that you could do that in most cases. I didn't realize that you could do it in all cases. But I will say that usually recursion is easier to understand if you're writing it and if you're reading it, if somebody else has run it. So you can actually, yeah, you can do factorial with what's called shifting, where you, rather than calling the function inside itself, you can set it up. Oh man, I've never actually written like a big one. The last time I wrote one was in school. I've never had to run into a recursive function that took forever. But if you think of it like a math problem where a factorial creates like a tree, you can actually just flatten the tree and do each calculation separately, and you can actually put them on different cores too if you're doing parallel processing. That's what he's talking about. That's what shifting is. Rather than doing it with depth, which is factorial, you do it with breadth. But yeah, you're right. You can transform any recursive function into a shifting, not a shifting function, but a shifting, what's it called? Solution, I guess. But here, this is what recursion looks like. So you just, this stays on the stack, and you call the next one, and you call the next one. And when you get to your base case, then it basically propagates back up with the results. This is a much better picture than I drew in the last time I talked about recursion. So anyway, we've written our factorial. Let's see if our tests still pass. And I actually have to go in half an hour. Oh, one of them failed. Which one? Return 0? Oh yes, because Yaki corrected me. Factorial of 0 is actually 1. So our test was bad. You gotta make sure your tests are not bad themselves. Because if you have a bad test, and you're designing your code assuming your tests are perfect, then you're gonna have a lot of trouble. But that's really all I wanted to talk about with test-driven development. Oops, that's not what I wanted. Maybe it is. Let me move that guy over here. I can't see how many people are actually... Wait, can I? What if I do this? Can I, this one? Okay, there are a few people in here. I have to go to work on a project in a few minutes, like 20 minutes. Does anybody have any questions? I know some people probably came in a little late. Does anybody have any questions about what test-driven development is, or why it's important, or why you would do it? The idea of writing your tests first to tell other people how your code should behave, and then writing your code after you've written your tests. It can be very useful. One of the benefits that I actually didn't mention is you write your tests first, then you write your code. And then you put your code live, or whatever you do with it. And then, 6 months down the line, somebody wants you to change your program. Now you have all these tests that can verify if your existing code still works. You don't have to do any additional work. Your tests are just there. So that's another benefit of it. Is if you write really good tests, you can be very confident that your program is good. As long as your tests are good, of course. So one thing, when Yaki was talking about, you can do, what's the phrase that you used? Shift reduce. He used shift reduce, which is probably another form of tail recursion. I've never heard people call them the same thing. But instead of doing something like this, you would basically calculate all these values first. Wait, is that right? No, you wouldn't. You'd calculate the topmost value. You calculate the topmost value first, and then you call the function once. Like, it's kind of hard to explain. But, okay, maybe graphically is a better way. So this way, we're calling the top function, but it's calling every inner function. So all of these all methods in Java, sorry. All of these methods are existing on the stack. With tail recursion, you basically have the result of this, or the result of this. I guess there are two ways to do it in this case. But you take one of the results, and you just store it, and then you just call a different one and take that result and store it. So rather than having all these methods running at once, you only have one method running at a time. And whenever it's done, you just store its result, and then you call the method with some other data. Let's see if I can actually do that, because I have like 15 minutes. I can probably do that. So, what is it? Int factorial. There, let's call it tail factorial. So it's going to return the same thing, but it's going to use it a different way. We're still going to have these. We're still going to have these. And whoops, what happened? Alright. Equals, not n. I equals 1, I less than or equal to ni plus plus. We're going to have a result equals, starts at 0, I guess. So rather than calling factorial inside of itself, we're just going to do the math right here. Result times equals, oh, it's not going to be 0, it's going to be 1. Result times equals I. And you can split this up if you have multiple cores or multiple CPUs or, you know, whatever kind of architecture you have. You know every value between 1 and n ahead of time. So if you're doing a factorial on like the number 1,000,000 and you're on some supercomputers, you could split this up into a bunch of different cores and they would all run concurrently, and you'd get your result very, very quickly. Did I do this right? If it's, well, there's an easy way to find out if I did it right. All we gotta do is, we gotta make this one return the other function for n. What's wrong? What's it complaining about? Missing return statement. Oh, duh. Yeah, I know. Fact, I spelled it wrong. Come on. And then we'll run our test and see if they still pass. Okay, I did it right. So the difference between let me get rid of this now since we know it works. So these two functions, although they do exactly the same thing for all inputs, these are two different ways of doing it. This way uses recursion. This function's calling itself. This does not use recursion. It does a breadth. I mean, you can probably just look by looking at it. What's the best way to explain this? This one does not call methods that live while other methods are living. Every time you call a method in any language, you're taking up space on the stack. Which, maybe I should talk about the stack in the next video, because it's pretty interesting. Every method you call, every function you call, goes on the stack. So if I'm trying to do factorial of 1,000,000, I'm probably going to get a Stack Overflow error, meaning I'm taking up too much space on the stack, because all those methods are being stored and they're waiting for each other to finish. But I can do my code like this, and only one method is ever running. If it were a more complicated problem, I'd probably have a method here instead of just a number if I was trying to find like a prime or something, like a large prime. This is one way you could do that. You don't want to find primes recursively. This way would be good. So with recursion, all these methods all the way down to the bottom are always existing on the stack. Like they're all running, even though, you know, they're paused waiting for each other. They're all running. They're taking up space in memory. But if you do it this way, you're taking up hardly any space. I mean, here's a variable and here's another variable. That's it. This isn't technically tail recursion because there's no recursion. I just realized, but this is basically the same thing. Streaming my other project, no. But it will be public release. It's Final Fantasy VII voiceover project. There's no programming involved for me. Sorry. A lot of people have been asking, maybe we should do a community project. I don't know what that would be. People can throw suggestions at my Twitter or something, or in chat. But I think a community project would be pretty interesting. It's not going to be anything that I'm currently working on, because I've got people for those, and those are all, you know, past inception. Like, we know where we're going. It would be really hard to pick up other people, and some of the things we're doing in those projects is pretty advanced. A lot of people who watch this are relatively new. Hey, Chicken Skill. You came just at the end, man. Because I have to. Oh, I have actually more than 20 minutes. Let me check what time I have to do this thing. I thought it was 7:30, but maybe it's 8. Meet with. Oh, it's 8. Okay, I have plenty of time. But yeah, I think a community project would be pretty cool. It could be a game. Does what involve unit tests only? Did I study CS? You mean C#? Is that what you're talking about? I've never seen it written CS. Oh, computer science. Yes, I studied computer science. I've graduated. I write software for a living now. Chicken Skill asked, does it involve unit test only? And I don't know what he's talking about. You mean test-driven development? When people talk about test-driven development, they're talking about unit test-driven development. There are other tests that you do when you're writing code, like integration tests and stuff like that. You can't unit test everything. There are just some things that you can never unit test, and that's fine. You unit test the smallest pieces of your code, and then you do integration test on basically everything else. I mean, there are other kinds of tests, but integration is, yeah. An integration test, for those who may not know, because this kind of lingo is pretty high up. But anyway, a unit test tests one small piece of functionality, usually one method in one situation. An integration test will test multiple objects together, or multiple methods together, multiple systems together, that kind of thing. Will you go on to other tests? No, probably not. There's not a lot of... I mean, there are tools to do integration tests, but they require a lot of setup, and there are a lot of different libraries for them. And there's not really a methodology behind integration tests. I mean, you do your unit testing, and that's a pretty good methodology by itself. Just test around your code, or write code around your tests. Integration testing is just making sure your overall program works. And there are a lot of different ways to do that. Like, there's no correct way. There are plenty of incorrect ways, but there's no single right way to test the, you know, the big picture. I primarily just wanted to talk about unit tests because they're very, very, very useful. You know, if nothing else, you know, not only do they serve as an API, they serve as a documentation for your code, even though they're not really documentation. But once you're done and once you've written your code as well, then you've got a bunch of tests that you can always use. You can always rely on them. If you change your code in the future, you have your existing tests that say the code that you wrote 6 months ago should still work. And you can just run the test to check. Otherwise, all you're doing is integration testing, and a lot of bugs can slip through integration tests. The other tests was what interests you. That's interesting. Is there anything in particular? Because there might be some big testing. There might be some testing not framework, but some testing methodology I'm not familiar with. Did you have something in mind, Chicken Skill? I guess, wonder if he left. Story test? You mean where you, oh, I know what you're talking about, yeah. So he's talking about story-driven testing, which is basically the idea of, you come up with a scenario of what your users might do. So you would say something like, okay, we're gonna have a user that does this with our program. And then you figure out everything that they could possibly want out of that one function, and you design around that. That's, for those who know what bottom-up and top-down are, story-driven is more of a top-down. You say, we want our users to be able to do X, and then you design around that. But unit testing is more like, it's bottom-up. It's, we want this functionality, We'll test for that, and then we'll build everything else together. So it's kind of coming from the opposite direction. Test-driven is bottom-up, story-driven is top-down. I don't do... Well, I'm not going to say I don't do it. We don't do too much story-driven development where I work. Most of what we do is test-driven and integration. Particularly for my group, where most of the things that we work on are already existing. We don't write that much... We don't write that many new products. We just maintain a lot of existing products, so we don't have too many stories to think about. Every once in a while, we'll get some new requirements. Every once in a while, we'll get some new requirements from somebody saying, you know, we want this app to do this, and then we'll add it. How can you not do integration test? I don't think integration tests are avoidable. I mean, when you're running your program and making sure it works right before you release it, that's an integration test. If you don't do integration tests, you know, the pieces of your code might work, but you have no idea if it's going to work all together. He says, so what I do for integration is story behavior-driven development, but I don't feel it's right that way. Huh. Do you do this, like, for yourself or for a company? Behavior-driven development is the same thing as test-driven development. It's called behavior-driven because you're testing around behaviors. Each unit test tests one behavior. With so what I do for integration is story BDD, but I don't feel it's the right way with kind of functional testing. You can see it all working together. But I mean, how do you test the whole thing before you release it, right? I don't know what you work on, if you're like smaller projects or if you're doing it for a business. There are some smaller projects where you don't need to do any kind of integration testing. Like if you're writing a library, you just need to make sure that your API calls work. If you're writing a library like, you know, a math library like these things, then you don't need integration testing. But usually if you're releasing a usable product that end users will end up using, usually you have to do integration testing. It's very rare that all of your code is modular. Usually things are meant to work together. But I don't know, maybe you work on libraries like this. Maybe I will talk about the stack. Not today, because I'm probably going to come up with PowerPoint slides. His BDD is done with Cucumber. I've never used Cucumber. It's I'm guessing that's a framework. I've heard of it, but I've never used it. We've got only so far 2 people participating. What else can I say about test-driven development? Never used Gherkin. The only like test-related frameworks that I've used are JUnit, AssertJ, and Selenium. Selenium to test the website stuffs. Change the check in line 9 to n equals 0. In line 9. Oh, this is if n is less than or equal to 0. Oh no, I see what you're saying. Yeah, you're right. That's the same thing. Nefarian123 had a good catch after Yaki made me change this line, because he pointed out that the n factorial of 0 is 1. So that's why it went down to that. In case you weren't here, what I used to have was if if n was less than 0, return 0. If n is equal to 0, return 0. And if n is equal to 1. This is what I, whoops, what am I doing? This is what I used to have, I think. Let me, if less than 0, if equals 0, and if 1's. Yeah, this is what I used to have. And then I combined these lines. But then Yaki pointed out that the factorial of 0 is 1, not 0. So that's why I got to whatever else I just had. Is that it? Less than 0, return 0, equals 0. Yeah, that's right. Chicken's kill is going to show me what he means. Yeah, you can post a link. It better not go to horse porn. You'll get insta-banned. Testing Diamond and the Pyramid. Alright, so he's talking about... Where are we? Which part of this are you talking about? Let me kind of read your chat again. Yeah, dog porn is acceptable. Yaki's asking what kinds of porn are acceptable. But anyway. So Chicken Skills talking about his cucumber and gherkin, and I don't know what this site has to do. It's just, you guys can check out the link. This is, I haven't read through it yet. Yeah, he says this, on this page it says unit tests in one of the, these are two different things. Most software organizations today suffer from what I call the inverted testing pyramid. They spend a maximum time building the end-to-end GUI test. Very little effort is spent on building unit tests. Hence they end up with a majority of their tests being end-to-end GUI tests, GUI tests. Some effort is spending on writing tests, integration tests, and a shocking 1 to 5% of their tests being unit tests. Yeah, so behavior-driven and unit-driven. Yes, the second drawing is what you want, where you want most of your code, as much as possible, to be unit tested. Because most code can be broken down into really small chunks that do really simple things. It's very easy to test simple things. That's the whole idea behind unit tests. You write simple code at the lowest level, and you write pretty simple, fast tests. And then you build everything together, and your integration tests are basically whatever you can't unit test. There are things that you can't unit test. There are a lot of things you can't unit test, but a lot of things you can. Actually, maybe I'll show everybody these pyramids. So the one on the left, this one right here, maybe I'll zoom this in a little bit. The one on the left, this pyramid that's upside down, this is how a lot of organizations do their software development, where they write the code first and then they test it. And then they do some integration tests and a little bit of unit tests. But he's saying what you should do, which is what I've been saying for the last almost an hour, is unit test as much as possible, 80 to 90%. And then you do your other tests that you can't unit test. This would be integration and stuff like that. There are tools called code coverage tools that will, when you run a unit test, they will actually remember which lines of code in your project were hit by the test. So they know every line of code that your test hit. Oh, that's fine. You didn't have to be here in that hour. I'm not blaming you for anything. I would never do that. But there are code coverage tests which when you run your unit tests, the code coverage tools will tell you which lines of code were tested. And at my company particularly, it's a requirement that all new software has at least 80% code coverage, which is what he's saying right here, 80 to 90% unit tests. Yes, they remember the execution path. All that is not covered is integration. Well, they're not mutually exclusive. Your integration tests will test stuff that's already unit tested. I mean, it has to. But your unit tests are what you build most of your code on. Because your unit tests, as long as your tests are good, this is the point I wanted to make. As long as your unit tests are really good, if your code passes the tests, then your code is automatically really good. Okay, that's really important. If you write super good tests and your code passes, then your code is really good. And it's important to have good code, because if you have good code, then your chance of getting bugs is very low. Your chance of the word escaped me. The maintainability of your code is very high. It's very easy for others to come in and understand your code and modify it. All that is not covered. Oh, I already read that. An example of 100% coverage of unit tests. So he posted a GitHub link. What is this? This is C, but that's okay because it's pretty much the same as Java. That's really a lie, but I have no idea what this does. In integration tests, you test routes. You can test routes in unit tests. I mean, that's what I'm doing here. You know, I'm testing over here in my here are my tests. So for the first one, I'm testing negative numbers, factorial -1. So I'm testing this route. And on one of these other ones, factorial of 0, I'm testing this route. So unit tests can test routes, the path that your code takes in a certain method. In integration tests, you test things that unit tests can't, usually because you're combining different code that does different things. Code that's too complex for a unit test. So for example, if you are making anything visual, by the way, anything that requires a person to verify would be an integration test. So if I was making a video game and I wanted to make sure that a character model is being loaded correctly and it displaying correctly, that would be an integration test. You can't write a unit test for whether every vertex on the model loaded in the proper place and looks good and the texture coordinates and all that. You can't really do a unit test for all of that. That would be an integration test, is actually running the game, seeing if the model loads properly. Visual is functional. I haven't heard functional testing used a lot. We might be talking about the same thing. Check that there's an input in the web page. Oh, is Cucumber like Selenium? Is it an automated web tester? Because our Selenium tests are unit tests. Actually, let me, if I look up Cucumber, I think I'm just going to get results for plants. Maybe I'll keep this on the page a little bit. I'm going to move this over. And I'm going to see what Cucumber is. I have heard of it, but barely. I was right. I just got the vegetable. Cucumber testing. Software that computer programmers use for testing other software. It runs automated acceptance tests. Okay. Written in BDD style. So let's see, features and scenarios. Oh, interesting. I've seen a language like this before. I don't remember what it was called. It was called a... was it called a functional language? I don't think it was called a functional language, but Cucumber does the same stuff like JUnit. Yeah, reading it, that's what it looked like. You're basically telling it, I'm giving you, you know, this input, I expect this input. JUnit's really popular, but if you guys haven't checked it out, check out AssertJ, because AssertJ can do some pretty interesting things that JUnit cannot. And aside from those interesting things, the two are almost exactly the same. I like AssertJ a lot better. Yeah, it's a good point, because there are a lot of people in QA teams who are not programmers. So, you know, they can't write code and they can't read code, but they can read something like, okay, if I give you a 5, I expect, you know, 20 or whatever. God, there was one language that I learned in college. We had to learn some of these, it was called esoteric languages. Basically languages that were weird. There was one language where you gave it some logical rules, and it would solve the logic puzzle, I guess, is what you'd call it. So you've probably heard of things like, okay, there are 4 balls on a table. There's a red ball. To the right of the red ball is a green ball. And the blue ball is between the red and the yellow. Find the order of the balls, or something like that. So you can solve problems like that in this language that I learned. Prolog, was that it? That sounds familiar. I don't remember. All I remember is that it was ridiculously slow. It was Prolog. I recognize this. Yeah, but all I remember about Prolog is that it was ridiculously slow. The class that I took was called Esoteric Languages, and we learned Prolog. I mean, we also learned Perl, which is not esoteric either. Perl is pretty common. We also learned Lisp. I like Lisp. I thought it was really interesting. Yeah, functional testing and functional languages are not the same thing. Brainfuck. I've seen Brainfuck. It's amazing. But actually, my favorite language is probably lolcats. Or lolcode, sorry. Lolcode. So a chunk of lol code would look like, you know, your program starts with, oh hi. And then if you have a loop, you say, I'm in your loop. And if you want a variable to store something, you say can has variable, or whatever variable name it is. And instead of return or exit to quit your program, it's okay, bye. I love lolcode so much. I've never written in it because it doesn't have features. Like, somebody wrote it as a kind of as a novelty language, but it's pretty great. Programming languages in college. 1 language a week for the entire semester with a quiz every Friday and a test every month. Ooh, that's pretty rough. Yeah, my, was it called oh, I take it back. I misspoke. It was not called Esoteric Languages. It was called Programming Language Pragmatics. Or maybe that was the name of the book. I can't remember. This was years ago. But yeah, we had to learn Perl, Lisp, Prolog, something else. I don't even remember everything we learned. We learned like 5 languages in 1 semester, so that's like a language every 3 weeks, something like that. Yeah, 1 language a week is not, that's not very good. Like, in 1 week you maybe can learn Hello World and a few other things. That's not really enough to appreciate each language. Oh, was this not for a CS program? Did you learn these languages in some other program? That's brutal. That's brutal. Oh, it was a CS program. Oh, I see what you're saying. They expected you to pick it up quickly because you were CS majors. Man, I can't even learn well, actually, I take that back. There are some languages you can learn in a week. You can't learn the whole API, but, you know, you can learn the syntax of a language in a week if it's something very similar to what you already know. Like, if you know C, you can probably learn Python and Neverwinter script and stuff like that. If you know Java, you can learn C# in like 5 minutes. Oh, okay, yeah. Not new paradigms every week, so. Leet Combo says, in his opinion, if they teach you 1 fundamental native language, you can easily pick up any other. I always say this. I always say the first language you learn is the hardest, because you have to learn to understand how computers think. You have to learn that they run, one function at a time, or one line of code at a time rather. You have to learn how variables are stored and passed into methods. But once you learn all that, any other language you learn is very easy. Syntax and grammar is the same across most languages. I mean, C, Java, C#, even JavaScript, Ruby, Perl, all these languages are very, very similar. Almost identical syntax in all of them. They taught you they taught you Java first, and most colleges are teaching Java first, and I actually agree with it. Although, if you're taught C first, you quickly learn about memory and the stack and that kind of thing, because you have to deal with it. In Java, you don't. So they kind of, it's very interesting, I think. Something that I found very interesting when I was going through my CS program. People who grew up on computers in like the 70s, right? They learned C first because, Java didn't exist. So they had to do the mallocs and the frees and everything like that. And then Java came along and they had to learn object-oriented. I always wonder, do they have a different way of thinking than people who learned with object-oriented first and then had to learn C after? That's always interested me. Because programming in C is very different from programming in Java, even though the syntax is pretty much the same. Because in C, you don't have objects with methods, you have structs, which is just chunks of data. And every function you write in C is, it's like, if you wrote all of your Java code with only static methods, then you'd be writing C. That's pretty much a good way to explain it, I guess. This is not quite true, but it's funny. Oh, they only taught you Java. Oh, that's bad. Yeah, at mine, aside from that one language class where I learned like 5 different languages, oh, we also learned assembly in operating systems class. Aside from those things, they taught us Java, C, and C++, because those are kind of the 3 big non-scripting languages. Alright, it's 7:30 where I am. We only learned Java, we didn't learn about indirection memory managements. Yeah, exactly. I mean, if you do enough Java, you will learn about how references, or C calls them pointers, you will learn how those work eventually because you'll write bugs. Like passing a object into a method and changing the object in the method, as opposed to passing a primitive in a method. So you'll learn those things very slowly in Java, even if people don't tell you, but yeah, you're absolutely right. If you're learning C, you're learning about the stack, and you're learning about memory, and pointers and things like that. It doesn't require well, yeah, it requires the unsafe API. I've actually used the unsafe API in a few useful ways. I have a serializer that can serialize primitives, strings, and arrays of primitives. And it is lightning fast. Like, to serialize an object in Java, a POJO, a plain old Java object, POJO, to serialize a POJO might take, 100 milliseconds. Yeah, this is Java. But to serialize a POJO with the unsafe library takes like 2 milliseconds. It's ridiculous how fast it is. And you can do other useful things, like you can throw exceptions without declaring them. You might think that's kind of stupid, but there actually are reasons to do that. Like, if you want to just print out a stack trace, that's a really good way to do it. Yeah, the Java serializer is ridiculously slow. It's so slow. But the thing is, it's reliable. You can serialize, complex objects with nested objects, and different versions of them will be separate. With an unsafe serializer, the reason I can only do primitives, arrays, and strings is because you have to code every object you serialize by hand. So I only chose to do primitives, arrays, and strings. What else did I do with that thing? You can use unsafe to find the size of an object, like the size in memory that it requires, a maximum bound of the size of memory it requires. You can use unsafe to lock a thread and unlock a thread unsafely. That's why it's in the unsafe package. There are a lot of cool things unsafe can do if you know what you're doing. If you don't know what you're doing, there are a lot of cool things unsafe can do to your computer. I mean, Java's safe enough that unsafe isn't gonna like format your hard drive. Because unsafe actually uses, does it use native Java memory? Unsafe doesn't use heap memory, it uses native Java memory, I think. The JVM memory. They teach you pass by reference on week 2? I mean, I guess it's something that is required pretty early because the whole idea of object-oriented is to write objects. And, you know, passing objects into methods is something that's very common. And if people are manipulating objects inside methods, they're probably wondering, how come my object's changing? And not my primitives. Yeah, that's... If you're new to programming, that might be hard to wrap your head around. But, yeah. I did not start with C, actually. The first language I was taught was Java. I self-taught a scripting language to myself before, but I didn't have to worry about memory. If you started with C, how would you teach C the proper way? Well, first you wouldn't teach pointers. You would just teach variables and, you know, the program flow. You'd do that first. Then you'd tell people, okay, now let's use strings, or, you know, character arrays, character pointers. And you very slowly explain how pointers work and how memory addresses work, like over the course of a week or 2 maybe. And then you say, oh, by the way, here's a Java object, it's just a pointer. And then people will instantly understand Java. Learn Java in 1 day from C programmers. I agree. Acting Rude has been saying some of these things. He says he thinks Java's a much better language for teaching people. I agree. Mostly because it saves you from your own mistakes. It does, you know, C will let you write outside of an array. C will let you access a null object. You know, things like that. Java will prevent you from doing most of that. You know, Java has a garbage collector, so it's very hard to do a memory leak in Java. It's not impossible, but it's more difficult. In C, if you forget one free, it's a memory leak. In Java, you don't have to worry about it. One thing that I haven't had to deal with, luckily, because I haven't done big C projects, is I haven't been in DLL hell. A DLL is a library, a dynamic linked library is what it stands for. So your program runs and it looks for those when it runs to get the code that it needs. That's essentially how it works. And so if you're writing a big C project, you're going to be importing like dozens, if not hundreds of DLLs from other people's projects or libraries. And getting them all to be compatible with each other is, from what people tell me, it's a nightmare. We have something similar in Java. We call it jar hell. It's almost the same thing, but it's a little bit more manageable due to things like Maven's a pretty good way to manage that. Maven is a system where you can kind of keep track of the versions of different code that you use. Okay, well, I have my thing to go to in a little bit, and I have not prepared for this other thing. Regarding the test project, did you create it using a framework or a library? Oh, this thing. Yeah, this is a reflection test, actually. I wish I could fit all of this on the screen. I got around using JUnit or AssertJ or something like that. The way this works is I have 2 lists of strings. I go through every method in this class using reflection. I ignore the main method because I don't want to get an infinite loop right off the bat. And then I invoke the method, which are just these guys. They're all static. And then if they return false, I add the name of the method to a failed test. If the method returns true, I add it to the list of successful tests, and then I just print it out at the end. This is not used commonly. I use this in really small projects because I have a shortcut for it. Actually, the code will probably... crap. Let me do this. I think this works. There we go. That's not much better. Was this test project? That's actually not much better. That might even look a little worse. But yeah, I'm going to make one of these tests fail just so you can see. So the output is just this thing. So test failed on the one that I just changed. Test passed, test passed, test passed. Yeah, that's what it is. It's a reflection test. The main method is just accessing every other method in this file and running them. And so if one of these methods returns true, it gets added to a list. If it returns false, it gets added to a different list. And then I print out the results at the end. So this is a homebrew unit testing framework. Just a quick and easy. I don't have to import anything. Oh no, I wrote these four. I wrote all of these. Alright, well, like I said, I have to go. I wish I could stay, but I have to go. Because I have Final Fantasy VII related things to do. Oh, no. Are you kidding? If my code that's, what is this, like 20 lines long? If my 20-line piece of code right here could generate my unit tests for me and run them, that would be ridiculous. Like, I would be a millionaire. There's no way. Yeah. Anyway, so I'll see you guys next time. I'll probably talk about the stack unless I find something that's more beginner-friendly. But the stack and things like pointers are pretty useful to know, so I probably will get to them someday. Alright guys, thanks for watching, and look forward to the Final Fantasy VII voiceover project, because I'm working on it. It's going to be awesome.